Here's integrated 3. It's problem 2-97. It says, graph and completely describe the function f of x equals square root x minus 3 minus 5. So I know that this is, it's going to have a shape like this. That's my parent function. And I know that we learned graphing form. It's y equals a times square root x minus h plus k. A is the stretch factor, h and k are my locator point. In the parent function, the locator point is at 0, 0. So I'm going to go ahead and adjust my graph to show the transformation that happens to it. And then I'm supposed to describe it completely also. Here's y and x. So this locator point, that's h and k. So x minus h. So h must be 3. Okay, let's do this. H, k. H must be 3 and k must be negative 5. So I'm going to put a point at 3, negative 5. There it is. And I know that the graph is just, it's going to point off this way. I might want to just plug in like a point, 1 or 2 points, just to, you know, get an idea of how it goes. So I'll do it in pencil in case I mess up. Okay, so what's a nice number I can plug in here? If I plugged oh no, I don't want to go out too far. I was going to plug a 12 in, because that would give me a 9. Actually, I am going to plug a 12 in, because that's 12 right there. And why would I want to plug a 12 in? Because I can go 12 take away 3 gives me 9. So I'm going to plug in a 12. And then 12 take away 3 gives me 9, and the square root of 9 is 3, and 3 minus 5 is negative 2. So now I have a point at 12. Luckily that was still in my graph. 12, negative 2. And I think that's sufficient because I'm just trying to sketch a graph. So that's all. Just going to show it like that. That's not really all though, because they did ask me to describe my graph completely. So I like to describe things like, is it continuous? I'm going to say it's is it like, you know, discrete or continuous? I'm going to say something about the domain and the range. So I'm going to say that the domain x is in between 3. Oh, and I shouldn't have done it that way. X is greater than 3. Let's just do it the easy way. It's greater than or equal to 3. So that's part of it. And then the range, y is greater than or equal to negative 5. So there's domain and range. What else? We like intercepts, but there's probably an intercept somewhere far away. Huh. Where can I get the intercept? I can get, if I plug in, I guess if I plug in 0 for y. Oh, if I plug in 0 for y, I'll get an intercept. So let's do that. So plug in 0 for y, I'd have 0 equals, okay, why am I doing this? Because I want to get an intercept. Oh, when y is 0. So I'm going to add 5 to both sides. And then I get 5 is equal to square root. Those cancel out. And then I'll square both sides. And then I have 25 is equal to, and then I'll add 3 to both sides. and then I'll have x is equal to 28. So there's an intercept at 28 comma 0. That's the x-intercept. Okay, so I'm just writing some things that I know about the graph to describe it. It's a domain, there's the range, there's the x-intercept. What else do we say about graphs? I could say it's increasing. Isn't that one of the things we say? If you said like four things, that's going to be enough for me to give you your points. There's more things you could say. You could say it's a square root function. It's not linear. It's non-linear. So I'm not going to say a billion things about it. That's all we have for now.